There is a number that sits quietly at the center of one of the most haunting questions in all of science. It is not a number born from mysticism or speculation. It was worked out methodically, carefully, by a physicist sitting in a conference room in Green Bank, West Virginia in 1961. The number was meant to be an estimate, a rough calculation of how many civilizations might exist in our galaxy alone, civilizations advanced enough to send signals across the void. And when the calculation was done, the answer seemed almost impossibly large. Tens of thousands, perhaps millions. The universe, it seemed, should be teeming with minds, staring upward at the same stars we stare at, wondering the same things we wonder. And yet, in the 7 decades since that calculation, in all of our listening, in all of our searching, we have heard nothing. Not a whisper, not a signal, not a single unambiguous sign that any other mind has ever looked up and asked the question. The silence is not just surprising. It is, when you sit with it long enough, one of the most unsettling facts in the history of human thought. To understand why this silence is so strange, you have to appreciate just how vast the stage is. We are not talking about a small sample. We are not talking about listening to a handful of nearby stars and shrugging. Our galaxy alone contains somewhere between 200 billion and 400 billion stars, 400 billion. And we now know from 2 decades of exoplanet discovery that planets are not rare cosmic accidents. They are the rule. Most stars have them. A significant fraction of those stars host planets in what astronomers call the habitable zone, the region where liquid water can persist on a surface, where chemistry can do its slow and patient work. When you run the numbers conservatively, you arrive at tens of billions of potentially habitable worlds in the Milky Way alone. And there are 2 trillion galaxies in the observable universe. 2 trillion. The arithmetic of possibility seems so overwhelmingly in favor of other life that the absence of any signal should feel like walking into a crowded room and finding it completely empty, with no explanation for where everyone went. This is the paradox. It carries the name of Enrico Fermi, who allegedly posed it as a lunchtime question, simple and devastating. If the universe is so large, so old, and so rich in the conditions that gave rise to us, where is everybody? The question sounds almost casual, but when you follow its logic, it pulls you toward conclusions that are either deeply humbling or deeply disturbing, and sometimes both at once. Let us start with time, because time is where the strangeness begins. The universe is approximately 13.8 billion years old. Our sun is about 4.6 billion years old, which means it formed well into the middle period of cosmic history. There are stars in our galaxy that are 10 billion years old, stars that could have hosted planets, planets that could have developed life billions of years before Earth even existed. If life tends to arise when the conditions are right, and if intelligence tends to follow given enough time, then civilizations could have had a head start on us of 1 billion years or more. 1 billion years. Consider what our own civilization has accomplished in a few thousand, in a few hundred, in the last 50. Now try to imagine what a civilization might look like after 1 billion additional years of technological development. The gap between us and such a civilization would be something like the gap between a bacterium and a physicist. And yet we detect nothing from these ancient minds. We find no megastructures around distant stars. We see no patterns in the cosmic microwave background that suggest deliberate engineering. We intercept no radio signals, no laser pulses, no artifacts drifting through the solar system. The silence is total. So why? There are several families of explanation, and none of them are comfortable. The first possibility is that the emergence of life, even simple microbial life, is so extraordinarily improbable that we are genuinely alone in the observable universe, or so nearly alone as to make no practical difference. This might seem like a retreat to a pre-Copernican arrogance, a return to the idea that we are special, that Earth occupies some privileged position in the cosmos. But there is a version of this argument that is not about arrogance at all. It is about chemistry, the origin of life, the moment when chemistry became biology, when a collection of molecules first managed to copy itself and begin the process of Darwinian selection, is something we do not fully understand. We know it happened here. We do not know how difficult it was. The origin of life may require a sequence of molecular accidents so specific, so improbable in their arrangement, that even given the staggering number of habitable worlds in the universe, it might have happened only once or only a handful of times. If the probability of abiogenesis on any given suitable planet is something like 1 in 10 to the 40th power, then even with 10 billion suitable planets in the Milky Way, you would expect to find no other life within billions of light years. We could be, in a very real physical sense, alone. But let us suppose that life is not so rare. Let us suppose that wherever chemistry has the right conditions and enough time, something alive tends to emerge. This seems plausible given how quickly life appeared on Earth after the planet cooled enough to support it. If life is common, then the question shifts. Where does the chain break? What is the filter that prevents the universe from being filled with communicating civilizations? There is a concept in this discussion that goes by a stark name, the Great Filter. It refers to whatever step in the development of a technological civilization is so difficult, so unlikely, that almost nothing makes it through. The filter could lie behind us. Perhaps the development of the eukaryotic cell, the kind of complex cell with a nucleus that eventually gave rise to all multicellular life, was the critical, improbable step. It took roughly 2 billion years after life appeared on Earth for the first eukaryotes to emerge. 2 billion years for what might have been an extraordinarily unlikely merger between two different types of single-celled organisms. If that step is the filter, if the transition from simple to complex cellular life requires a confluence of accidents so specific that it almost never happens, then we might be among the only complex life forms in the galaxy, and the silence makes sense. But there is a more troubling possibility. The filter might not be behind us. It might lie ahead. Consider what it means for a technological civilization to develop. It requires not just intelligence, not just curiosity, not just the ability to build tools and manipulate matter. It requires stability. It requires a civilization to survive its own technological adolescence, that dangerous period when it has developed the means to alter its environment or release energies powerful enough to threaten its own existence, but before it has developed the wisdom or the institutional structures to manage those means responsibly. We are living in exactly that period right now. We have nuclear weapons capable of ending our civilization many times over. We are altering the chemistry of the atmosphere in ways that will reshape the conditions for life on Earth for thousands of years. We are beginning to develop biotechnologies whose consequences we cannot fully predict. The question of whether any civilization successfully navigates this period, whether intelligence tends to be self-limiting on cosmological timescales, is not an abstract philosophical puzzle. It is a question with direct implications for our own future. If the great filter lies ahead of us, if technological civilizations almost universally fail to survive their own power, then the silence of the universe is not a mystery at all. It is a warning. It is the universe telling us something about the typical fate of minds that reach our level of capability. Every civilization that came before us would have broadcast a brief signal into space, grown capable of hearing faint transmissions across the light years, and then gone quiet, not because they left, not because they lost interest, but because they were gone. This is the most sobering version of the Fermi Paradox. Not that we are alone because life is rare, but that we are alone because intelligence tends to be self-extinguishing. that the silence we hear is the silence of a vast cosmic graveyard. There are other explanations, and they vary considerably in their strangeness. One possibility, sometimes called the dark forest hypothesis, is that the universe is inhabited but deliberately silent, that civilizations have learned through bitter experience that broadcasting your existence is dangerous, that the cosmos is a place where contact between civilizations with asymmetric capabilities tends to end badly for the less advanced party. On this view, every civilization capable of hearing us is also capable of knowing that any civilization we might contact is either less advanced than us, in which case we pose a threat to them, or more advanced than us, in which case they pose a potential threat to us. The optimal strategy for survival on this view is silence. The galaxy becomes a dark forest where every hunter moves quietly and shoots first at any sound. It is a bleak picture, but it is not physically impossible. Another family of explanations involves the nature of communication itself. We have been listening primarily in the radio spectrum because that is what our technology first gave us, and because radio waves travel well through space and require relatively modest energy to produce. But a civilization a million years more advanced than us might find radio transmissions as quaint as we find smoke signals. They may be communicating through channels we have not yet conceived of. Quantum entanglement across vast distances is not obviously impossible from a theoretical standpoint, though it faces serious barriers related to information transmission. Gravity waves, neutrino beams, structures in space-time itself. We are in the early days of listening, and we are listening in a narrow band of an enormously wide spectrum. The silence might simply reflect the limitations of our instruments and our imagination rather than the absence of anyone speaking. There is also the possibility that advanced civilizations do not broadcast, not because they are hiding, but because they have moved beyond the kind of expansion and communication that would leave a detectable footprint. Perhaps sufficiently advanced civilizations turn inward, creating simulated or virtual environments of such richness and complexity that the external physical universe becomes less interesting than the universes they can build for themselves. Perhaps they miniaturize, concentrating their civilization into structures of extraordinary density and computational power that would be invisible to our instruments. Perhaps they convert themselves entirely into patterns of information running on substrates we would not recognize as technology. On any of these paths, a galaxy full of ancient civilizations might look to us exactly like an empty galaxy. And then there is the sheer scale of the problem, which is worth sitting with directly. Even if there are thousands of civilizations in the Milky Way at this very moment, they would be separated by distances measured in thousands of light years. A signal sent today from a civilization 1,000 light years away would not arrive here for 1,000 years. If they sent a signal in response to detecting us, the round trip would be 2,000 years. Communication on cosmological scales is not a conversation. It is more like a message in a bottle thrown into an ocean so vast that there is no guarantee any two messages ever cross the same path in the same millennium. The practical impossibility of contact is not just a matter of technology, it is baked into the geometry of space-time itself. The speed of light is not just a speed limit. It is a fundamental constraint on the causal structure of the universe, a hard boundary on how much of reality any single observer can ever be in contact with. Which brings us to something worth pausing over carefully. The observable universe, the portion of the cosmos from which light has had time to reach us since the Big Bang, is a sphere roughly 93 billion light years across. But the universe itself may be vastly larger, perhaps infinitely larger, depending on its geometry. If the universe is infinite and roughly uniform in its distribution of matter, then not only is there almost certainly other life out there, there's almost certainly an exact copy of you out there, sitting in an exact copy of the room you are sitting in right now, reading an exact transcript of these same words. This is not metaphor. This is a straightforward consequence of infinite space and finite probability. In an infinite universe, every possible configuration of matter that is physically allowed must be realized, and must be realized infinitely many times. The question of whether we are alone becomes almost incoherent at that scale. Of course, we are not alone. The question is whether we could ever know, whether any signal from those other minds could ever, in any physical sense, reach us. And here is where the cosmology becomes genuinely haunting. The universe is not static. It is expanding, and the expansion is accelerating. The distant galaxies are moving away from us, not just because of some initial velocity imparted by the Big Bang, but because the fabric of space itself is stretching, and that stretching is speeding up, driven by whatever dark energy turns out to be at its deepest level. The consequence of this acceleration is that there is a finite region of the universe from which signals can ever, in principle, reach us. Beyond a certain distance, space is expanding so fast that even light traveling toward us at the maximum possible speed will never close the gap. Those galaxies and any civilizations within them are already, in any physically meaningful sense, permanently beyond our reach. The universe is not merely large, it is in the process of becoming forever unreachable in most of its extent. So we are left with this picture: a universe of staggering age and scale, rich in the chemistry of life, filled with countless worlds that might have given rise to minds capable of the same questions we are asking, and a silence that might mean any of several things, none of them easy to accept. We might be genuinely alone, the product of a sequence of accidents so improbable that they occurred only once in a galaxy of 400 billion stars. We might be early, living in the first chapter of a cosmic story that will eventually be full of voices, but is for now almost entirely quiet. We might be surrounded by a galaxy that was once full of civilizations that did not make it through the filter that we are now approaching. We might be listening in the wrong way for the wrong kinds of signals, with instruments still too primitive to detect what is actually there. Or perhaps the silence is teaching us something about the nature of intelligence itself, about whether minds that are capable of asking the deepest questions are also in some way constitutionally fragile, prone to the same curiosity and ambition that allows them to reach for the stars, and also, if they are not careful, to burn themselves out in the attempt. The universe has been running its experiment for 13.8 billion years. The data are in. And the data say that whatever the conditions are for the emergence of a technological civilization capable of making itself heard across the galaxy, those conditions are either extraordinarily rare or extraordinarily perishable, or both. That is not a comfortable conclusion, but it is the one the evidence supports. And if there is any lesson in it, it may be this: the silence of the cosmos is not just a fact about other civilizations. It is a question directed squarely at us about what we intend to do with the brief and improbable window of time that physics has given us to make noise.